In Section 2, we will discuss how pathogens grow and what specific conditions they need to grow. We will also discuss which of these factors we can control and how time and temperature can be used to our advantage. An acronym commonly used in food safety to remember these conditions is FAT-TOM. FAT-TOM is a mnemonic device that is used to describe the 6 favorable conditions required for the growth of foodborne pathogens. It stands for food, acidity, time, temperature, oxygen, and moisture. We will discuss each of these conditions in detail as our class continues. The first condition that pathogens need to grow is food. Pathogens need a food source in order to multiply and grow. Pathogens grow best in food sources that are rich in nutrients and protein. Examples typically include foods such as milk, eggs, meat, and fish. The second condition that pathogens need for growth is acidity. The pH scale ranges from 0 to 14. A pH between 7.1 and 14 is alkaline, while a pH between 0 and 6.9 is acidic. A pH of 7 is neutral. Pathogens grow well in food that has a neutral to slightly acidic pH in a range of 7.5 to 4.6. The third condition is time. It takes a certain amount of time for pathogens to grow in foods to a level that can cause illness. Food should not be kept in temperatures between 41 degrees Fahrenheit to 135 degrees Fahrenheit for more than 4 hours. If foods are kept between this temperature range for more than 4 hours, they should be immediately discarded. The fourth condition of FAT-TOM is temperature. As we mentioned already, pathogens grow best in the temperature range between 41 degrees Fahrenheit and 135 degrees Fahrenheit. This zone is also known as the danger zone. Foods need to be cooked to an appropriate temperature to destroy any pathogens that may be present. Once foods are cooked, they should be held at 135 degrees Fahrenheit or higher. Cold foods should be held at 41 degrees Fahrenheit or below. The fifth condition for pathogen growth is oxygen. Almost all foodborne pathogens require oxygen to grow. However, some pathogens are anaerobic, meaning they do not require oxygen. The sixth and final condition of FAT-TOM for pathogen growth is moisture. Pathogens need a certain amount of moisture to grow, which is measured by water activity. Foods that have a water activity level less than 0.85 are not considered a time temperature control for safety or a TCS food. Of the 6 FAT-TOM conditions, we can only really control 2 of those conditions at the restaurant or food service level. Those 2 factors are time and temperature. Since these are the 2 factors that we are able to control, we will focus most of our time and attention on them. We can minimize the amount of time that foods spend in the danger zone or the temperature zone between 41 degrees Fahrenheit and 135 degrees Fahrenheit, or we can refrigerate and freeze foods appropriately and cook foods to their proper temperatures. In regards to temperature control, we use the process of cooking to destroy the organisms and pathogens that may be present in foods. To prevent time temperature abuse, you will need to minimize the time that foods spend in the temperature danger zone. To do this, you need to establish the best way to monitor your time and temperatures when prepping, cooking, and cooling foods. Thermometers should always be readily available and easily visible in your coolers, refrigerators, and freezers. It is also helpful to keep a log of temperatures and the times that they are taken. Temperatures should be checked and recorded on a regular and frequent basis. Here we see an example of a bimetallic stem thermometer. These make testing food temperatures easy and convenient. To calibrate a thermometer, you can use the ice point method. To do this, fill a large container with crushed ice and water. Then submerge the thermometer stem or probe in the water for 30 seconds. You must then hold the calibration nut and rotate the thermometer head until it reads 32 degrees Fahrenheit or 0 degrees Celsius. Remember to keep the thermometer in the ice bath while you are adjusting it. There are a few general guidelines you should know when using thermometers and checking temperatures. Thermometers and their cases should always be kept clean and sanitized, and thermometers need to be calibrated on a regular basis to ensure that they are accurate. You should never use glass thermometers to monitor food. When you're taking internal temperatures, you should insert the thermometer into the thickest part of the food product, which is generally the center. Thermometers may fluctuate at first, so wait until you have a steady reading before recording the food temperature. Now that we know more about food temperatures and the appropriate ways to record them, we can discuss what the proper cook temperatures for certain foods are. For whole or ground poultry products, such as chicken, turkey, or duck, the internal cooking temperature needs to reach 165 degrees Fahrenheit for 15 seconds. This also applies to stuffed poultry or poultry used as stuffing. When reheating leftover foods that include TCS or time temperature control for safety ingredients, you must reach an internal temperature of 165 degrees Fahrenheit for 15 seconds if it will be used for hot holding. If the dish that includes TCS ingredients is raw, you should cook it to the proper internal temperature for the raw ingredient. Ground meats such as ground beef or pork have an internal temperature requirement of 155 degrees Fahrenheit for 15 seconds. Injected meats must also reach an internal temperature of 155 degrees Fahrenheit for 15 seconds. Any steaks or chops that are pork, beef, veal, or lamb must reach 145 degrees Fahrenheit on the food surface and must have a noticeable color change on the food surface. For roasts of the previous meats, the internal temperature must reach 145 degrees Fahrenheit for 4 minutes. The internal temperature for fish is 145 degrees Fahrenheit for 15 seconds. Stuffed fish, or fish used for stuffing, must reach 165 degrees Fahrenheit for 15 seconds. Ground, chopped, or minced fish must reach 155 degrees Fahrenheit for 15 seconds. Shelled eggs that will be used for immediate service must reach an internal temperature of 145 degrees Fahrenheit for 15 seconds. Shelled eggs that will be hot held for service must reach 155 degrees Fahrenheit for 15 seconds. Any fruits or vegetables that will be hot held for service must reach and be held at 135 degrees Fahrenheit. Foods that are considered TCS foods that will be cooked in the microwave, such as eggs, poultry, fish, or meat, must reach an internal temperature of 165 degrees Fahrenheit for 2 minutes. Now we will look at specific situations in which we can control time and temperature. To start, we will look at the 4 approved methods for thawing TCS or time temperature controlled for safety foods. The first approved method is to thaw frozen foods in a cooler or refrigerator that is 41 degrees Fahrenheit or lower. You can move a frozen food from the freezer to a refrigerator to allow the frozen food to thaw. Pictured is an example of an improper method for thawing. Foods cannot be thawed out at room temperature or left unrefrigerated. The second approved method is thawing foods as part of the cooking process. Frozen foods can be thawed as part of the cooking process as long as the temperature is met to destroy pathogens. The third approved method is to thaw foods in the microwave. However, if a microwave is used to thaw foods, the foods must be cooked immediately after microwaving with no interruptions in the prep and cooking process. The fourth and final approved method for thawing is to submerge frozen food under running water at a temperature of 70 degrees Fahrenheit or below. To use this method, you must ensure that there is a small stream of water running over the food product to float off any loose particles. Any thawed portions of the ready-to-eat foods must not rise above a temperature of 41 degrees Fahrenheit. Thawed portions of raw animal foods that require cooking must not be above 41 degrees Fahrenheit for more than 4 hours, including the time the food is exposed to running water and the time needed for preparation, or the time it takes under refrigeration to lower the food to 41 degrees Fahrenheit. In the picture on this page, we can see some shrimp that has been left in a tub of water to thaw. This is an example of an improper thawing method. Running water must be present to remove any particles that become loose from thawing so as not to contaminate the food and potentially cause foodborne illness. Cooling cooked food quickly is a necessary process to limit the growth of pathogen in foods. To cool foods quickly and efficiently, there are a few steps you can take. Reducing the size of food helps to cool the food faster. Cutting large foods into smaller pieces, such as a large roast or turkey, will cool foods much faster. You should also divide foods into smaller, shallower containers. An example of this may be to separate a large pot of chili or soup into smaller pans. You should use containers that facilitate heat transfer and keep them loosely covered. Using rapid cooling equipment such as blast chillers or freezers is also helpful. You can also effectively cool foods quickly by using ice baths or ice paddles, or even by using ice as an ingredient in the food. Properly cooling foods must occur in your food establishment to prevent foodborne illness. Bacteria and pathogens grow rapidly when foods are in certain temperature zones between 41 degrees Fahrenheit and 135 degrees Fahrenheit, known as the temperature danger zone. To address this, we have to cool hot foods in a reasonably swift time frame. The food code states that cooked foods have to be cooled from 135 degrees Fahrenheit to 70 degrees Fahrenheit within a maximum of 2 hours. Foods then have to be cooled from 70 degrees Fahrenheit to 41 degrees or below within 4 hours. This creates a total of 6 hours for foods to be cooled from 135 degrees Fahrenheit to 41 degrees Fahrenheit or below. Note, however, that the critical cooling from 135 degrees to 70 degrees must be done within the first 2 hours. If you cannot cool hot foods from the 135 degrees Fahrenheit to 70 degrees Fahrenheit within 2 hours, you can either reheat the food to 165 degrees Fahrenheit and try another method of cooling, or you can discard the food. TCS foods, or time temperature controlled for safety foods that are reheated for hot holding, must be reheated to an internal temperature of 165 degrees Fahrenheit for 15 seconds within 2 hours. If the reheated food has not reached 165 degrees for 15 seconds within the 2 hours, you must discard it. When you are holding TCS foods, you must protect the foods from contaminants. An example of this may be a sneeze guard or covering. The internal temperatures of food should be checked at least every 4 hours. Any hot food should be held at 135 degrees Fahrenheit, and cold food should be held at 41 degrees Fahrenheit or less. Any equipment used in your facility should be able to hold foods at the proper temperature. Food should not be stored directly on ice beds unless it is whole fruits and vegetables or raw cut wrapped fruits and vegetables. Next, we will discuss what the danger zone is, how foods get into the danger zone, and why we want to keep foods out of the danger zone. The danger zone is the zone between 41 degrees Fahrenheit and 135 degrees Fahrenheit. Remember that those temperatures are the maximum temperature for cold-held foods and are minimum for hot-held foods. The zone between our hot and cold holding temperatures are called the danger zone because it is in this zone that bacteria and pathogen growth is the most efficient. Bacteria and pathogens grow quickly in this zone, and it is for this reason that we try to get food out of the danger zone as quickly as possible and then keep it out of the danger zone. In this diagram, you can see how foods enter and exit the danger zone. This diagram shows 3 examples of different foods and their relation to the danger zone. They are the no-cook, same-day, and complex process. We will talk about each one. In the no-cook process, we have an example of a sandwich that contains ready-to-eat fillings. These can be foods such as cold tuna sandwiches, canned chicken, or lunch meats. In this example, we are using a food that starts cold at 41 degrees Fahrenheit or less. This could be your tuna, canned chicken, or lunch meat. The food is assembled cold, meaning that there is no heating or cooking process. The food is held cold at 41 degrees Fahrenheit or below and is served cold at 41 degrees or below. In this example, the food never leaves the maximum cold holding temperature of 41 degrees or below, so it does not make any trips through the danger zone. In the same-day process, we have a hamburger as our example. The hamburger patty starts as the cold food at 41 degrees Fahrenheit or below. Then the patty is properly cooked through the danger zone to its appropriate internal temperature of 155 degrees Fahrenheit for 15 seconds. It is then prepared hot and held at 135 degrees Fahrenheit or above and then served hot. In this example, we went on 1 trip through the danger zone when we cooked our cold hamburger patty to the appropriate internal temperature. In the complex process, we have catered meals or hot-held leftovers. In this example, the food starts cold at 41 degrees Fahrenheit or less. The food is then cooked through the danger zone to its appropriate internal temperature. The food is properly cooled and stored, which means the food will go from 135 degrees hot holding temperature to the 70 degrees within a 2-hour maximum, and then from 70 degrees to 41 degrees or below with an additional 4-hour maximum. After the food is stored in cold holding, the food will be reheated through the danger zone to 165 degrees Fahrenheit in under 2 hours, and then hot held at 135 degrees Fahrenheit and served hot. In this example, we made 3 trips through the danger zone. The first trip was the initial cooking process from cold to hot. Once the food was cooked, we made our second trip through the danger zone as we cooled our cooked food down to be stored cold. Our third and final trip through the danger zone was when we used our cold stored food and reheated it to hot hold and serve. As we have already mentioned, bacteria growth can be controlled with time and temperature. In order to use time as a public health control, procedures should be written and prepared in advance. It is also important to note that establishments that serve highly susceptible populations cannot use time as a public health control for eggs. If you are using time only as a public health control for TCS foods, you can choose to use a 4-hour maximum hold time in a temperature danger zone. In order to use the time as a public health control, the initial temperature of the food must be 41 degrees Fahrenheit or less, or 135 degrees Fahrenheit or higher. Any foods that will be served this way shall be marked to indicate when the 4-hour time maximum is up. After the 4 hours maximum, the foods must be discarded. For cold foods, time can be used to control bacteria growth for a 6-hour maximum hold time in a temperature danger zone. The initial temperature of the cold food must be 41 degrees Fahrenheit or below and must not reach a temperature over 70 degrees Fahrenheit within the 6-hour maximum. Food should be monitored at frequent intervals to ensure that the warmest part of the food does not reach above 70 degrees. The food shall also be marked with the time that the food was removed from the 41 degrees Fahrenheit or below, and the food shall be discarded once the 6-hour maximum has been met. You shall discard the food if it reaches 70 degrees Fahrenheit or above at any time before the 6-hour maximum. Once the food is removed from the proper cold temperature, it must be cooked and served, or served ready to eat, or discarded within the 6-hour maximum.